Students, let us revise again. During determination of molar mass of solute, that is your MB here, what do we find? We find that during dissociation, number of moles of solute particle increases, hence colligative property increases, and hence molar mass is always less than expected. And during association, what do you find? Number of moles of solute particle decreases. As you see here, acetic acid in presence of benzene, 2 mole of acetic acid gives you 1 mole of acetic acid, and hence in this case, number of moles of solute particle decreases. Therefore, colligative property decreases, and hence molar mass is always more than expected. So class, there was a problem how to determine molar mass of solute with the help of these 4 colligative properties. So finally, Van 't Hoff gave some suggestions to overrule all these factors, and that is called Van 't Hoff factor. And it is symbolized as I. So class, we studied 4 formulae in colligative property, that is Pa0 minus Ps upon Pa0 equals to Nb upon Na, and he simply suggested that this Nb upon Na should be multiplied by Van 't Hoff factor I. Similarly, elevation in boiling point, you studied delta Tb equals to Kb into M. Van 't Hoff suggested that it should be also multiplied by Van 't Hoff factor I. Similarly, delta Tf, you studied Kf into M. Van 't Hoff suggested multiply by Van 't Hoff factor I. And you also studied osmotic pressure, pi equal to CRT. Again, you are supposed to multiply by Van 't Hoff factor I. So what is Van 't Hoff factor? So Van 't Hoff factor I can be given as observed Cp upon normal Cp. Or, since you know that Cp, colligative property, is inversely proportional to molecular mass, in the last lecture I already told you. So now we can write normal molecular weight upon observed molecular weight. Normal means molecular weight which is theoretically calculated, and observed means with the help of this formula we can find out observed molecular weight, and by dividing both we get Van 't Hoff factor I. Now class, the next topic, relation between Van 't Hoff factor I and degree of dissociation. It is given by alpha equals to I minus 1 upon n minus 1. So what is alpha? Alpha is your degree of dissociation, that is studied in class 11. I is your Van 't Hoff factor, and n number of moles of solute particle after dissociation. Let us take one example. NaCl, 1 mole, when dissolved in water, gives us Na positive and Cl negative. So we get 1 mole Na plus and 1 mole Cl negative. So we are getting total 2 moles after dissociation. Therefore, N is 2 here. So if you put N here 2 and Van 't Hoff factor we are getting by those formulas, then we can also find out what was the degree of dissociation of that ionic solute. This was your first. Second, relation between Van 't Hoff factor I and degree of association. Only 2 things happen. Either dissociation will happen or association will happen. I've already told you that when acetic acid is dissolved in benzene, it dimerizes to give you this. So we started with 2 moles and now we are getting only 1 mole. So number of mole is less. That's why we can call it that 2 mole of acetic acid is associating to give us 1 mole acetic acid here. So What is the formula here? Alpha equals to 1 minus I upon 1 minus 1 by n. Again, let us write out here. Alpha, what is alpha? Alpha is degree of association. I, you all know, Van der factor. And n, number of moles of solute particle associating. In this case, 2 molecules of acetic acid is associating, so the value of n equals to 2. Now student, question comes, how this acetic acid diaminizes in benzene? So, I'll explain it over here. Acetic acid forms hydrogen bond. Acetic acid forms H bond. See how? See, 1 mole of acetic acid. Another acetic acid. O, highly electronegative. H, less electronegative, so it will develop positive charge because here is again O. Similarly here, H will develop positive and O will develop negative charge, and now they are going to form hydrogen bond. Students, this diagram must be shown in your fear register. Let us solve a numerical on the basis of Van der factor. See, the question is already on the board. Find elevation in boiling point when 5.85 gram NaCl, molecular weight 58.5, is dissolved in 50 gram H2O. If NaCl goes 75% association in water. Given KBH2 equals to 5.12 Kelvin kilogram mole inverse. Class, we are going to use the formula which has already been told to you. Delta Tb equals to I into Kb into M. M is the molarity. But we don't know I. So until unless we can find out I, we will not be able to solve delta Tb. So how to find out I? So we'll go for relation between degree of dissociation and Van der factor, that was alpha equals to I minus 1 upon n minus 1. Since class NaCl dissociate to give us 2 moles, therefore n equals to 2. Let us put it here. And 75% dissociation, so out of 100, 75 dissociating, so out of 1, 75 by 100 gives you 0.75. So let us put in this formula, that is formula number 1. So delta Tb equals to Van der factor, we are supposed to calculate. Sorry class. First we'll find out I. So alpha is 0.75, I minus 1, and n value you know variable 2 minus 1. So 2 minus 1 gives you 1. 1 multiplied by 0.75 gives you 0.75, and 1 comes from this side giving I value 1.75. Now we'll put up this 1.75 in formula number 1. So delta Tb equals to I 1.75, Kb 5.12. Multiplied by molarity, weight of solute 5.85, multiplied by 1000. Class, this is the molarity expression we are using over here. Then divide by molecular mass 58.5, and then how many grams solvent? 50 grams. Solve it. Here you get 0.1, 20 multiplied by 0.1 gives you simply 2. 1.75 multiplied by 5.12 multiplied by 2. So 1.75, 10.24, 17.92 degrees C. So this is your answer. delta TB equal to 17.92 degrees centigrade. So this is the way we can solve abnormal molar masses numerically. First, again I repeat it again, percent division was given to you. With the help of this, find out the value of phi. Out of 100, 75 dissociate, so out of 1, 0.75, so we put value 0.75 here. I we are going to calculate, and give value we have already calculated here. That gives you 1.75, and then putting in this formula, we get delta TB equal to 17.92 degrees centigrade. Find the osmotic pressure of solution obtained by mixing 34.8 gram K2SO4 in water to give 200 cc solution at 27 degrees C. If potassium sulfate is 25% dissociated in water. So class, since the nuclear on osmotic pressure, and since ionic solute and it is going to dissociate, so we'll use formula phi equal to I into C into R into T. What is C? C is the molarity. So let us open it. I, in place of molarity, I can write WB upon MB multiplied by volume in cc per 1000 multiplied by R multiplied by T. But again, since the potassium sulfate is 25% dissociated, until unless we calculate I, we are not able to find it out. So let us first calculate I. So alpha equals to I minus 1 upon N minus 1. K2SO4 when dissolved in water dissociate to give us 2K positive plus sulfate 2 negative. So class, we started with 1 mole. Now we are getting how many moles? 3 moles. So value of N is 3. And alpha out of 100, 25% is out of 1, 0.25. I minus 1, N की value 3, 3 minus 1. So 3 minus 1 gives you 2. 2 multiplied by 0.25 gives you 0.5. And if I add 1 here, I get I की value 1.5. So in the next step, we are going to use this formula. So pi, I is 1.5 here. Concentration, that is in molarity, weight of solute 34.8 into 1000. Molar mass has been given to us 174 into volume in cc, 200 cc. Into R into T, 300. Let us solve it. This 24.63 multiplied by 5, and this gives you 0.2. And here we are getting 1.5. So 0.2 multiplied by 5 gives you 1. 1 multiplied by 1.5 into 24.63. So class, we get 36.945 atm osmotic pressure. So class, I have already discussed 2 numericals on Vent-Off factor. There is no problem in Vent-Off factor. Previously we used to write only pi equal to CRT, but since we know that ionic solute will be dissociating, so we are using Vent-Off factor. So please remember class that ionic solute dissociates. Ionic solute dissociates. Acetic acid associates. solutes which neither associate nor dissociate are urea, glucose, sucrose, etc. So class, until now we have been doing numerical only on urea, glucose, sucrose, so we are not using Vent-Off factor. But today, in today's class, we have taken up NaCl, potassium sulfate, and we know that they are ionic solutes, so they will dissociate, and if they dissociate, then you will have to always use Vent-Off factor. So class, as I already told you that in solution we will be discussing three topics. First topic was your Raoult's law for solution of two volatile liquids. Second topic was colligative properties. In colligative properties we got four: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. And then we studied Vent-Off factor, and that completes my colligative properties.